Hi everyone, I hope you all are doing good. So in today's session we will see this question, ninth standard foundation question. Okay, if x is equal to 1 upon 5 plus 3 root 3 and y is equal to 1 upon 3x minus 3 root 3, then find or prove that xy square plus x square y is equal to 5 upon 2. This we have to prove. We have been given the value of x and y, and we have to prove or we have to find the value of xy square plus x square y is equal to 5 upon 2. So students, whenever you are getting encountered by such type of question, first you have to recall and first you have to bring in your mind the thing is, in this type of question we are never having anything in the denominator with root. So we have to see and we have to focus that how to get this root eradicated from there. And for this we know very well that we have one method that we have studied, that is called as rationalization. Okay, so first by doing rationalization of x and y, we will root out or we will eradicate this root, and then after we will see what to do. Okay, now see, so our first step will be to rationalize the value of x and y. So if you will rationalize, you know very well students, we have been given x value as 1 upon 5 plus 3 root 3. Okay, now the process of rationalization is involved as we have to multiply and divide with its conjugate. What do you mean by conjugate? Means we will have the same expression with a different sign. Okay, here we are having the expression as 5 plus 3 root 3. So when we will multiply and divide by its conjugate, its sign will get changed, that is 5 minus 3 root 3 upon 5 minus 3 root 3. The basic principle or basic concept behind this is that both of them will get cancelled and we will left with our same expression. Okay, in mathematics we are having this liberty to do any change provided condition that the balance of the equation or expression should not be disturbed. Okay, so we are basically rationalizing here the value of x. Now while rationalizing, students, the numerator will be multiplied to the numerator. So any expression multiplied by 1, we will get the same expression as its result. So at the numerator we will have 5 minus 3 root 3, and at the denominator, if you will see it carefully, students, see here we are having 5 plus 3 root 3 and multiplied by 5 minus 3 root 3. So here I would like to explain you in detail 5 plus 3 root 3 into 5 minus 3 root 3. At both the expression, we are having the value of A as same and B as same. Means what? A plus B into A minus B. And we know very well A plus B into A minus B is equal to nothing but A square minus B square. So here same concept we are going to apply, that is A square minus B square. Now A square means what? 5 square minus B square means what? 3 root 3 square. Now 5 square means simply it will become 25 minus, now 3 square means this square is on 3 also and here at root 3 also. Okay, so when you will find the value of 3 square, then you will get 9. In between them multiplication sign is there, and if you will find the value of root 3 square, this square and square root will cancel as both the operation are inverse to each other. So they will cancel. So here multiplied by 3. Now we will get 25 minus 27, that will be equal to minus 2. I hope you are getting this calculation. So basically here directly I will write it as 5 square means 25 minus, I have already explained you how this 27 will come. So here the value of 5 minus 3 root 3 upon, now when you will subtract this, then addition of integer students that we have studied in 6th standard. So we will subtract it and we will consider the sign of greater number. So 27 minus 25 we will get 2, and 27 is greater having sign minus, so we will get minus sign at the result. Okay, now similarly this is the value of x that we got. Similarly we will find the value of y. So we are having y is equal to 1 upon 5 minus 3 root 3. Now again we will have to rationalize it, and I will not explain you the same thing in depth again and again. So basically I am going to rationalize, means I will multiply by its conjugate and divide by its conjugate. Okay, so 5, here we are having minus sign, so in its rationalization we will have its plus sign. So 5 plus 3 root 3 upon 5 plus 3 root 3. Again if you will multiply at the numerator, you will get the same expression, 5 plus 3 root 3 whole divided by, again here students, a plus b into a minus b, that is a square minus b square. When you will find a square, you will get 25, means 5 square is 25 minus 3 square is 3 3 is 9, and a square root of 3 and a square will cancel each other. Finally we will left with 3, means 9 into 3 will give us 27. Okay, so here we will get 5 plus 3 root 3 upon minus 2. Now we are having the values of x and y in rational form. Okay, rational form means we are not having its denominator any root, or we have eradicated the root numbers. Now what is our expression, students? Where our expression is xy square plus x square y. Now this we have to prove as 5 upon 2. We are having the value of x, we are having the value of y, but here in the expression we can see that we have been asked y square also, x square also. So different methods are there. As you know that for solving one question of mathematics we are having number of methods. The thing is our method should be correct. So here I am going to solve this. I am not going to involve myself in finding out the square of x, then a square of y, then we will add both of them, and then we will get 5 by 2. So what basically I am going to do, see, in both of the expression we can see that we can take xy as common. Okay, so if I will take xy as common, then here we will left with y only, and if we will take xy from here, then we are left with x only. Now see here, this reduces our workload, our burden. Now we can prove it with the value of x and y only. We need not to calculate the value of x square and y square also. Now same thing, 5 upon 2. Now put the values of x and y in this expression, or separately you find x into y, then separately you find x plus y or y plus x, and then you multiply both of them, you will get 5 by 2. You are having different method, as I told you, as I am repeating again and again. For solving one question we are having different method, students. You can adopt any of the method and you can solve, provided condition that you have to solve it correctly. Okay, now here we are having the value of x and y. So how I am going to do? First I am going to multiply x and y. So let us see how much we are getting x into y. Okay, x we are having 5 minus 3 root 3 upon minus 2, and y we are having as 5 plus 3 root 3 upon minus 2. Basically we have to multiply these two numbers, students. Okay, now see, I am going to multiply the numerator separately, denominator separately. If you will multiply the denominator, minus 2 into minus 2 will give you plus 4. Finished. Now come to the numerator. Numerator, a plus b into a minus b, as you can see. See, a plus b, a minus b. Very easy. Or otherwise, if you are not able to identify such type of identities, then you will have to go in multiplication separately all the terms. Okay, so depends on you, how will you do. So I am going to apply here a square minus b square, because there is no use if we are not solving the question smartly. Why to work more? So a square minus b square. A square means we have already found 25, minus b square means minus 27. Okay, now when we will subtract this, then how much we will get? Again we will get minus 2 upon 4. When we will simplify this to the lowest term, simplest form, then what we will get? 2 2s are 4 and 2 1s are 2, means minus 1 upon 2. What we got? The value of x into y we got as minus 1 upon 2. Now what we are left with? X plus y. Now let us find the value of x plus y. Now x plus y. Okay, how much we are having x, students? We are having x as 5 minus 3 root 3 upon minus 2. Okay, and in between plus, now this time in between plus sign will be there. 5 plus 3 root 3 upon minus 2. Okay, now how to solve this? See, first what we will do? We are having different method. We can multiply this minus sign at the numerator. Again we can multiply this minus sign at the numerator also. So I am going to multiply this minus sign at the numerator, and denominator I am going to make it free, as we have studied in rational numbers in a standard form. So there we have to do what? Two steps we had to do. What? The numbers should be in simplest form and there should be no negative sign at the denominator. Okay, so now I am going to multiply the minus sign of the denominator at the numerator. So we will get minus 5 plus 3 root 3 upon 2 plus minus 5 minus 3 root 3 upon 2. I hope you understand, students. Now we will take LCM as 2. Now this will be same expression will be written 5 plus 3 root 3 plus minus will become minus 5 plus minus again minus 3 root 3. Now 3 root 3, 3 root 3, both of them will cancel each other, students. How much we will left with? Minus 5 and minus 5. Both minus 5 and minus 5 will become minus 10 upon 2. If you will simplify this, you will get 5. That is with minus sign. Finally, you will get minus 5. Okay. Now come to the expression, our original expression. What was our original expression? This one. Xy into x plus y or y plus x is equal to 5 by 2. So we will write xy into x plus y or y plus x, don't get confused, both are same thing, is equal to 5 upon 2. Now the value of x into y we have already found out, students. How much we have found out? Minus 1 upon 2. You can see, for your reference also I will show, otherwise you will get confused that from where the value of xy has been calculated. See, I have calculated the value of xy here as 1 upon minus 1 upon 2, and the value of x plus y I have calculated as minus 5. Okay, so same I am going to put the values here. Okay, so minus 1 upon 2 into minus 5 is equal to 5 upon 2. Now minus into minus will give you plus, students, and 5 into 1 will give you 5 upon 2 is equal to 5 upon 2, and hence it is proved. So like this we are proving and we are approaching such type of questions, students. I hope you understand it and you enjoyed the session. The session was quite productive for you. I will zoom it out so that if you want to write, you can write, you can copy the solution in more convenient way, students. So this is your complete solution of this question. I hope that you understand and you enjoyed the session. Thank you.